gotten our P? How many of us? Less than 30%. Oh, we have so many people that have gotten our P. So what's our P? Anyone get the same answer?
No.
You got the same answer with AJ? Who got a different answer?
I got 56, 623.
56,
Yes.
623. Who got the same? You got the same answer with who? AJ. Who got the same answer with? Okay, let's solve this. So from this, you have our P. Our age was $2 million. It was P into 1 plus rate 0.095 all over N. What's our N? Our N is 4. Hence you have 4 times our T. Our T is what? 45. Hence you have $2 million equals P times. Please use your calculator. 4 times 45. Do this basic operation and raise everything, raise to whatever you have. Then what you have there? What will I have there? What will I have there?
I'm gonna get it. Don't worry.
68.376.
No, that's not right.
68 points.
376.
How many of us got the same thing? 68.376. Correct. Okay, now at this point you make P the subject. That's dividing both sides is the coefficient of P, which is dividing this with 68.376. Divide this 68.376. From here, this will cancel this. Hence, $2 million divided by 68.376. $2 million divided by 68.376. What do we get?
You get
29,250.
I was wrong.
29,000.
Yeah. 29,250.
Okay, so this will be the initial deposit, the deposit that will make who invested this? That will make Canon, Andrew, and 2 million after 45 years. Someone got this, right? That's the same thing that we got.
I had 29,249.
49, that's that's the same thing.
Those 4 cents.
Yeah,
I'll take the dollar more.
that's still okay.
Half percent.
That's still okay. You are yeah. So you know, sometimes I get this question a lot. How all these mathematics that we are studying, what's the application? What's the application of this? How does it work? Right. So I want to show like a demonstration of linear and exponential function. But first of all, let me ask: if you are given 2 options, and one is to be given $10,000 per day for 30 days, $10,000 a day for 30 days. Or to be given $10 to be doubled each day for 20 days. So which option will you go for and why?
Second option.
So the first one is, let me demonstrate this. The first one is $10,000. To be given per day. So all the days. So you have $10. So this one, day 1, day 2, day 3, day 4, day 5, 6, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this will lead to 30. Till 30. Why this will stop at 20? This will be stopping at 20. 19, 20. So the option is to be given this $10,000 and it will be given to you every day for the next 30 days, or to be given $10 and it will be doubled each day. To be doubled each day. So whatever you get, $10 will be doubled. The next day, whatever you have will be doubled. It will be doubled. $20 will be doubled. $40 will be doubled. Another like the doubling, which means exponential function. The number of times the principal is coming. So these options, which one will you go for and why?
The second one,
The second one, why?
because it'll be more money overall. Probably.
In 20 days. Who else? Who is going for option 1? So everyone is going for option 2. Good. Good. So let's see. So for this first one, look at what happens. So if I'm giving this, for the first day, I'll have $20,000, $30,000 for second day, $40,000, $50,000, $60,000, 70, 80, 100,000 dollars, $110,000, $120,000, 130. Okay, so for this, for the first day, then you are giving this. This money is doubled for you to give $20, and this is also doubled to give $30, 40. No,
Double.
doubled. It has to be 40. Why this will be 80? This will be 160. 3002.
Wait, no, just 320.
64. Right?
You have one too many zeros on those.
Where?
You go from 160 to 3200. Should be 320.
So this should be 1028. I should add 1 0 back.
Yeah.
Then multiply it by 2.
256
Eh?
zeros. 2,560.
2
560.
60. Multiply by 2.
5120.
Multiply by 2.
10,240.
Multiply by 2.
20,480.
Wait.
Alright, then it's 81. No, wait, that's not right. Not yet.
So this will be what?
49.
4096.
4060. This will be what?
8192.
Yeah. 20.
Okay. This will be what?
And 6384. 0.
This will be what?
32468.
Yeah, it'll be 327.
327. Yeah.
Okay.
327. Oh man.
327.
You're doing really well.
Okay. Next.
And 656. 530.
5 or 6.
One number.
536
5. Yeah.
6 5 what?
6 5.
3
Yeah. 3.
6 0 0.
No, 536.
5 3.
655,360.
Okay. So let me call on one person. Just one person. Repeat yourself.
655,360.
Good.
Can you do the next one?
Okay, so even without getting to the point of 20 days, you can see how this thing works. This is the power of exponential functions and linear functions. So simple interest is more like a linear function. Why compound interest is more like an accumulation of wealth over time. So linear function is more like something like this, where you have x. So we have the dollars here, and we have the days. So 1, 2, 3, 4, number of days. So this is going this way. It's more like a linear function. This is linear function. Right? But for exponential, we have something like this. Almost the same thing. You will notice that this comes like this. At a point, at the initial stage, it will look as if nothing is happening. It will look as if nothing or minimal, something very minimal is happening. But over time, it grows this way and skyrockets to skyrockets so high. So this is the type of exponential function. So this is basically the difference between the compound and simple interest. Because of the power here, because of this power of n, we're having n not only here, but the n that is making it to skyrocket is this exponent here, which is the power. Because everything here is not coming the number of times. The n, how many times is accumulating, and the t number of years. So it means that everything here is coming number of times. Yeah? But like you say a raised to the power 4. It means A times A times A times A. Alright? If you say 2 raised to the power of 5, 2 times 2 coming 5 times and not 2 times 5. That's correct. Okay. Okay, let's solve this. Someone invests $50,000. I'm sure we have not solved this. I'm sure we have not solved something like this. 2004. Oh, we have solved this. So, someone invests $50,000 into an annuity. Into an index annuity that's averaging 5% per year, compounded quarterly. Hence, who is investing this time? Let me know. Okay. Blake, right? Blake is investing. P is $50,000. So, and the rate, averaging at the rate of 5%, 0.05. So from this, and it's compounded quarterly, that means our N is 4. So at this rate, how many years, that means time, we're looking for our time. How many years will it take Blake to have $3 million? So the final amount. So how many years will it take you to have this money in your account? So basically, we are plugging, if I say that from our formula, we are plugging in everything and we are finding the value of t, just like we did. So from this, we have A as what? $3 million equals P into 1 plus our rate is 0.05 over 4, right? 4 times T, that is 40. 40. We have our P. We have our P. We have our P here. And our P is $50,000. $50,000. So from this point first, you have to divide both sides with $50,000. This will cancel this. 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 We'll be left with 300. 300 divided by 5 will give you what?
60.
60. Good. You have 60 equals 40. What do we have here? 0.05 divided by 4. You add 1. What do we get?
1.0125.
1.0125. Good. So what do you do at this point? You know, I said something earlier. If you get to this point where what you want to make the subject is in the power, there's something I need to do.
Take the log of both sides.
Thank you. Take the logs of both sides. Log 60 equals log 1.0125 power 4t. Right? So from here, we have log 60. From the basic law of logarithm, this can come down to give everything will now be log 60 equals 40 log 1.0125. Right? So what do we do next? What do we do next? What do we do next?
Divide.
Good.
Times 5 or log number that I can't read right now.
Okay, thank you. So we are dividing both sides with the coefficient of what we have here. 4 log 1.0125. You have 4 log 1.0125. Hence, log 1.0125 divided by log 1.0125. 4 divided by 4. Hence, our t is equal to everything that we have here. Now, do this operation. Log 60 divided by 4 log 1.0125 will give you what? That will be our value of t. Hence, our t will be what?
82.398 years.
T what?
82.398.
2.398 years. So approximately 82 years. Good. I want to solve something similar. Let me change some of these values. Let's say this is 20,000. And this is 3%. And this is compounded semi-annually too. And we want to get to $500,000. Now, I want you to use this information here to solve for your t. You can do this in pairs, in group, interact. Can we do that? So, all this information here, apply the information to we have 3 minutes. If you are not done in 3 minutes, that's okay. If you are not done in 3 minutes, that's very much okay. less than a minute. Talk less than a minute. Have many of you gotten our tea? How many of you? How many of you? Okay, let's go 1 more minute to know if we have more numbers. Let's go 1 more minute to know if we have more numbers. Ensure that you are following. Less than a minute. Can work in pairs, work in groups to get our tea. Okay, how many of us have gotten our tea? Good, we have more numbers. So, what's our tea?
108.098589 years.
Okay. Did any of us get a different answer? All of us got the same thing. So let's go. So what's our P? Okay. We'll go with our 500,000. Our A is 500,000. That equals our P is what? 20,000 into 1 plus what? Our R is 0.03. This is compounding semi-annually. That means twice per year. Hence you have 2 times T. Divide both sides with 20,000. This will cancel this. We're left with everything raised to power 2t. So if you do this basic operation, if you simplify this, what are we going to have? 0.03 divided by 2.
1.015.
Plus 1.
Yeah.
Plus 1 will give you what?
1.015.
Okay. So what do we do at this point?
Take the log of both sides.
So take the log of both sides. Equals log 1.0152t. This implies log 25 equals 2t log 1.015. So what do you do at this point? You make t the subject, divide both sides with the coefficient of t, which will give you will cancel out. Hence, our t is equal to everything that we have here. And if we do this, simplify this, we'll get what? 108
Years.
years. So it will take, who invested this? No one. No one invested this. I have not invested. I have not invested. Who wants to claim this?
I mean, I'll take it if I can have multiple investments. Free money.
Okay. So it will take Hunter 108 years.
Oh. Make sure you make it.
It
I'll
will
get
take
there
you
eventually.
108 years. The only thing you need to do is just increase your rate. This is compounding
More money.
semi-annually. If you start compounding maybe monthly, that means it will be 2 times, 12 times in a year. Your rate will go high. And also your rate, if the percentage increase from 3% to 10%, I think you can make that this amount, with this deposit in less number of years, maybe less than 80 years or so. You're able to double your rate to 6% or 7%. Then on that number of N is so powerful because if you're changing that rate, if you're having your N and your N is going to 12, it means that every 10 times 12, so it will skyrocket. Good. So now the next topic is HCF and LCF. So HCF means highest common factor. While LCM means lowest common multiples. So the HCF of 2 or more numbers is the greatest common factor of a given number. So what we are doing basically in this is HCF and LCM. So these are the initials. So what you are doing basically is you are for HCF, highest common multiples. If you want to find the HCF of 2 numbers, you want to find the factors that they have in common. Right? In the sense that if you have you have to find the HCF of the following. Find the HCF of the following. LCM of 12 and 8. So simply, solution. So I like to use this method, this long division method. You place 12 and place 8. You find a number that can divide both 12 and 8. And make sure to give you a perfect square and not decimal. And that number, will, normally I like starting from the lowest number. 2. If 2 divide this here, we have 6 here. We have 4 here. Right? What else can divide both? 2 can go again. We have 2. Here we have 3. Here we have 2. Which other number can divide both? None. So at this point, the HCF is equals 2 times 2, which is 4. Very simple. Then for number 2, HCF of 48 and 54. So you place this 48, 54. So what number can divide both?
2.
2. Let's go with 2. Here we have 24. Here we have what? 27, right? So which other number can divide?
You're gonna do 3.
3 can divide, right? If you have 3 here, we have Here will give you what? 8. And here will give you what? 9, right? So which other number can divide both?
Nothing more.
Nothing more. So we are going with that our HCF is equal to 2 times 3 equals 6. Very simple. 3. Let's find the HCF of 27, 81, and 18. Place our box 27, 81, 18. So which number can divide through? 9?
Yes.
9? Okay, so I like going from I like making it simple so that everyone will follow along. 9 can divide through. I like starting from 2. I'll check for 2. If 2 cannot divide through, I'll check for 3. Can 3 divide through? So if you divide by 3, what do we have? Here we have 9.
27.
Huh? This is correct. What about this 81?
47.
27. What about 18?
6.
What else can divide through? 3. This will go 9 divided by 3 will give you 27 divided by 3 will give you no. What about this? 2. What else can divide through? Nothing else. Hence, our HCF is equal to 3 times 3 equals 9. Number 4. Now let's go with this bigger number. So I want to find the LCM of 96, 108, and 180. Which number can divide through?
2.
So 96 divided by 2. 48. What about this? What about this? Good. What else can divide? Which other number can divide?
2 again.
2 again. Here we have what? We have 24 here. Here we have what? Is it 27 or 26? 27. Oh, it will be 52. 26 27. Here we have what?
45.
Good. What else can divide through? What else can divide through?
3.
Okay. 24 divided by 3. 8.
8.
What about this?
9.
What about this? Good. What else can divide through? What else? Nothing else. Hence, our HCF is equal to 2 times 2 times 3. 2 times 2, 4. 4 times 3, 12. Good. Can someone help me with the cleaning? Everything we are signed. So let's find the LCM of the following. Let's continue. Find the HCF of the following. Here, this one is 24 and 36. 2. You have 32, 40, 56. Here you have 18, 30, 42. Therefore you have 8, 72, 90, 9, 27, 45, 63. Ten. 4, 8, 48, 60, 84. 11, 54, 72, 90. 12, 96, 120. 13, 36, 54, 72. 14, 20, 30, 50. 15, 84, and 98. All for LCS. Let's find this, then we move over to LCM, which is highest common multiples, lowest common multiples. So let's finish up with this HCF first. So for number one, is 24, 36. 24, 36. We start from 2. What else can divide 2?
3.
3. Good. What else can divide 2?
Are you done there?
We are done. Hence, our HCF is equal to 2 times 2 times 3. It was 12. Good. Number 2. $32, 40, 56. What can divide through?
2.
Start with 2, right?